Hey everyone, so you clicked on this link because you want to learn how to graph linear inequalities. Or maybe you clicked on this link and you want to learn how to graph a system of linear inequalities. Well, in this video, I'm going to show you both things. Now, if you have no idea what inequalities are and you want to go through the basics, then consider clicking on this link up here to learn what are linear inequalities. On the other hand, if you know what the basics are, but you want to challenge yourself and know how to solve inequalities, then click on this other link up here to solve inequalities. But if you're really good at the basics, you know how to solve inequalities, then keep watching this video and we're going to graph some linear inequalities. My name is Peter. Grab your calculator and let's get started. Let's start off by understanding the objective of today's video. The first objective is to graph linear inequalities in two variables. After we've understood that concept, we'll be able to solve systems of linear inequalities by graphing. I'm also going to remind you briefly the difference between a linear equation and a linear inequality, which we're learning today. Equations are basically math statements that are joined with an equal sign, and linear inequalities are math statements that contain a less than sign, greater than sign, or less than and equal to, or greater than or equal to sign. So here's an important definition of linear inequalities. A linear inequality in two variables has an infinite number of solutions. These solutions can be represented in the coordinate plane as the set of all points on one side of a boundary line. So here's a picture of what our final answer is going to look like. We're going to be shading the region that contains the values that make the inequality true. Something else that's important: for us to distinguish the different inequality signs, if it's just a less than or greater than sign, we'll be using a broken line. If the sign is greater than or equal to or less than or equal to, we'll be using a continuous line. The first example we're going to look at involves graphing linear inequalities in two variables. Our inequality is y is less than or equal to 3 over 5x minus 5. So the first thing that we're going to do is we're going to try to graph only an equation from this inequality. So y equals to 3 over 5x minus 5. Once we have the equation, and then we will graph the inequality later on. If you want to graph a linear equation, you need to identify 2 points on the graph and then connect those 2 points. This line here, the first point is going to come from this -5, which is the y-intercept. So we know that the line is going to cross at where y is -5. The second point that we need to make a table. And in this table here, we're going to choose an x value and then we'll plug it into the equation to get the y value. So I want to choose a good x value that's going to simplify this fraction. The good x value is going to be 5. So when you substitute 5 for x here, you're going to have 3 times 5 is 15. 15 divided by 5 is 3. 3 minus 5 equals to -2. So our 2 points are going to be the y-intercept here, which is -5, and also 5, -2. And then we'll join that line, we'll join the 2 points with a straight line. The final step is to determine how do we show the inequality. We need to either indicate all the infinitely many values that are above the line here or that are below the line here. And the way we do this, we're going to use the zero test. In our inequality here, I'm going to substitute y with the value of 0 and the x with the value of 0. So when I plug in 0 for y, I'm going to get 0 is less than or equal to 0 times this fraction is 0. 0 minus 5 is -5. And then I ask myself, is 0 less than -5? The answer is no. That means in my graph here, I want to choose all the values that are not including 0. So my final answer is going to be a graph that looks like this. In the second math problem, we have y is greater than 2x minus 5. So the first thing that we're going to do is to write that inequality as an equation, y equals to 2x minus 5. This is going to make it easy for us to come up with a line. The first point is going to come from this -5, which represents the y-intercept. And I'm going to indicate that value on my y-axis down here. So now we need a second point. And the second point, we're going to use a table, x and y, and I need to use any x value here. I substitute it for x and then I can calculate y. So I'm going to choose the number 3 for this particular example, but you can choose any value for x. So 3 times 2 is 6. 6 minus 5 equals to 1. On the graph here, I'm going to indicate where 3, 1 is, and then I'm just going to join those two dots with a broken line. Now, the final thing that I need to do is I need to determine if I'm going to shade the left side of the graph or the right side of the graph. And I'm going to use the zero test. The zero test says you take 0 and substitute it for y, and you also take another 0 and substitute for x here. 0, when you replace it for y, you'll just have 0 is greater than 0 times 2 is 0, and 0 minus 5 is equal to negative 5. So what I want to ask myself is 0 greater than negative 5? And the answer is yes. What that means is the origin is on the side of the line where we want to include all of those infinitely many values. So I'm just going to go ahead and shade that side. In the third example, we have y is greater than negative 4. So the first thing that we're going to do is change that inequality into an equation. So y equals to negative 4. And then the next thing is I'm going to use this negative 4 as the first point on my line. Negative 4 is the y-intercept. So on the graph, I'm going to indicate that point with a dot where negative 4 is. Since this is an equation with only one variable, this is going to be a straight horizontal line. So when I look at my inequality here, I see that it's just a greater than sign. So the line here is going to be a broken line. Finally, we need to determine whether we need to shade above this boundary or below the boundary. So we're going to use the zero test. I'm going to take the number 0, substitute where y is, and then we're going to test and see if the inequality is true. So 0, is it greater than negative 4? And the answer is yes. Since the answer is yes, I need to shade where the 0 value is. Everything that where 0 is where all the possible values that make the inequality true. And that's where I'm going to shade. So now let's work on a few questions that involve graphing systems of linear inequalities in two variables. Another way that this topic is commonly known is simultaneous linear equalities. So we have two inequalities here, and we want to graph the two inequalities, and then we're looking for where the two inequalities are going to overlap. So we'll graph the first one. Y is less than or equal to negative x minus 2. We'll change that inequality into an equation so that we come up with a line. And then I'm going to use the negative 2 here as my y-intercept. And then I'm going to indicate that on the graph. The next thing is I'm going to use a table to figure out the second point so that I can connect them. And I have x and y, and I'm going to choose x is 2 for this particular example. I'm going to take the number 2 and substitute where x is. My y value is going to be negative 4. So where 2, negative 4 is, I'm going to indicate that on the graph, and I'm going to connect the 2 points with a straight continuous line. After that, I need now to figure out, do I shade the right side of the boundary or the left side of the boundary? So we're going to do the zero test. I'm going to substitute y with a 0 and x with a 0. So that's going to give me an inequality that is 0 less than or equal to negative 2. And is that true? And the answer is no. That means where the origin is and all these values in that region are not valid values. So I only need to shade below here, and that's the region. So let's go to the second inequality. Y is greater than or equal to negative 5x plus 2. And the first thing I'm going to do is to write a linear equation. And then from here, I can see that the positive 2 is the y-intercept. So I'm going to indicate that on my graph here with a red dot. And then I need a second point. So I'm going to use a table, x and y, and I'm going to choose the value of 1 for x. So when x is 1, 1 times negative 5 is negative 5. Negative 5 plus 2 is going to give me a negative 3. So where 1 comma negative 3 is, I'm going to put a second red dot, and then I'm going to connect those two red dots with a straight line, and then I need to figure out, do I shade the left side or do I shade the right side? So we'll do the 0 test. So where y is, I'll put a 0, and where x is, I'll put a 0. And then I'll get 0 is greater than or equal to positive 2. Is that true? The answer is no. That means I should not include 0 as the side that has the valid values. So I'm going to shade the right side here. Now, once I shade the right side here, I need to look for where the red region overlaps the blue region, and it's simply this zone down here. So any value that you choose in this little triangular zone here is the solution of this system. In the second example, we have two inequalities. Y is less than or equal to 1/2 x plus 2 and y is less than negative 2x minus 3. We are going to graph each inequality one at a time. So the first one, we're going to convert it into an equation, and then after converting that inequality into an equation, we identify the y-intercept. So the y-intercept in this case is the number 2. So we're going to indicate the positive 2 on the y-axis here. So the second point, we're going to get it by making a table. So the table here is going to be xy, and I'm going to choose an x value of positive 2. You can choose any x value that you want. So I chose positive 2 here because I'm looking for a number that can simplify this fraction. Numbers that can divide by 2 are ideal. So 2 divided by 2 is 1, 1 plus 2 is 3. So where 2, 3 is, I put my second dot, and then I'm going to connect those two points with a straight line. The final thing is to figure out, do I shade the left side of the boundary or the right side of the boundary? And to do that, I'm going to use the 0 test. So I'll substitute y with 0 and x with 0. And then when I substitute those two variables, I'm going to have 0 less than or equal to positive 2. Now, is that true? The answer is yes. That means I'm going to shade the side that includes 0, 0. Final equation, I'm going to change it from an inequality into an equation, and then after that I'm going to identify the y-intercept, and it's negative 3. So on my graph here, I'm going to put a red dot where negative 3 is. My second dot, I'm going to find it by using a table, and in this table I'm going to use positive 1. When I substitute positive 1 for x, I'm going to have negative 2 minus 3 equals to negative 5. So where 1 comma negative 5 is, I'm going to put my second dot, and then I'm going to connect those two dots with a broken line because my second inequality only has a less than sign. Once we finish drawing that line, now we need to figure out whether we need to shade the left side or the right side. So to do that, I'm going to use the 0 test. I'm going to substitute y with a 0, and I'm going to substitute x with a 0. If you substitute x with a 0, you only remain with negative 3. So is this inequality true? The answer is no. So if it's no, that means we should not include 0 as part of the solution. So it's going to be all of the region on the left side. So once you shade that region, identify the region that has two overlapping regions. So the red region and the blue region is identified by this space that is around the black line here. All the values that are in this space here form solutions of this system of linear inequalities. Here's the pro tip. Whenever you're graphing linear inequalities, remember to always check the inequality before you draw the line. And that's the pro tip. So after working on a couple of examples, here are 3 exercises that you should try on your own. The third question here, it's a little bit more challenging than the other 2 questions. But if you have any questions, you can always go backwards in the video, watch it again, and then try the third question. The third question, you'll have to solve the first inequality before you can graph it. Good luck.